Alright, in this question we're going to look at the normal distribution and how to calculate percentages between certain values if the values are distributed normally. So this question says, on a math test, the scores were normally distributed with a mean score mu equal to 72 and a standard deviation sigma equals 7. So those were the symbols for mean and standard deviation. What percent of students scored between 70 and 90 on this test? So in order to do that, we should make a sketch first of this distribution to see what it looks like. Well, a normal distribution has a bell curve shape, and the mean is in the middle, and in this case the mean was 72. And then normally we put the standard deviations, each click to each side represents a standard deviation. And so you could go up 2 to 3 standard deviations on each side. And we can put these numbers here. So if the standard deviation is 7, then here would be 79. And we go up another 7, that would be 86. And another 7, 93. And then if we go back 7, this would be 65 here. And another 7 from 65 would be 58. And then 51. And so the question though is asking, what percent of students score between 70 and 90? Well, if we look at our curve, neither of those numbers lie in a standard deviation. 70 is about here, and 90 would be about here. So essentially what we want to figure out is this area underneath the curve between those two numbers, 70 and 90. So the way to do that is to find z-scores for each of those values. So let's do that. The z-score, you might recall, is the value minus the mean over the standard deviation. So for each value we can find this z-score. So for 70, let's say we want the z-score for 70. That's going to be equal to 70 minus 72 over the standard deviation of 7. And we calculate that out. And we get negative 2/7. That's approximately negative 0.29 if we round it to 2 places. And the z-score for 90 is equal to 90 minus 72 over 7. And that's 18/7, and that's 2.57. So what do we do with these z-scores? Well, we need to convert these z-scores to percentiles. In order to do that, we need to use a table. So most statistics books would have a table that looks something like this. And if you look at this table, you have z-scores down the side and then percentiles in the middle. And look at the diagram at the top. Here's the bell curve, and these percentiles are the actual areas, percentages to the left of whatever z-score you're given. So we have two z-scores. We have negative 0.29. Let's look that up. Negative 0.29, we have to go to this side here. Negative 0.2, you scroll across all the way to 9, and that's 0.3859. And then we have a z-score of 2.57. Well, that's positive. So we look here, 2.5, and then 7. Scroll across all the way to 7. We get 2.57 is 0.9949. So once we have these z-scores, we have to determine what to do with them. Well, these z-scores give us percentages to the left. These percentiles, sorry, give us percentages to the left of these z-scores. So negative 0.29 is the z-score for 70. So 70 is here, and to the left, this white area here would be 0.3859 or 38.59% right here on the left-hand side. And similarly, the z-score for 90 is 2.57. So here's 90, and that z-score gives us a percentile of 99.9949. So to the left of 90, there's 99.49% of the data. But we want what's in between these z-scores, between 70 and 90. And so to figure that out, we have to take difference of these two. So we need 0.9949 minus 0.3859. And we calculate that difference. And we get 0.609, which is, as a percentage, 60.9%. And so the answer to our problem, what percent score between 70 and 90? Well, 60.9%. Or close to 61%.